Hey everybody, today we are going to talk about rotations. Okay, a rotation is often called a turn, and it's a transformation in which a figure is rotated around a point called the center of rotation. So a rotation goes something like this. It just rotates around this way. Okay, so the number of degrees the figure turns is called the angle of rotation. If the angle is positive, the rotation is counterclockwise. So this is a positive rotation. If it's negative, it's a clockwise rotation. It goes this way, which seems backwards to most people. There is a reason for it. I did learn it in college, and I don't remember what it was. But it does make sense once you find out why. Okay, in any rotation, the image and pre-image are always congruent. They're just always congruent. So here's what we've got. Here's my center of rotation right here. Here's my pre-image, so I've got this arrow, and this thing is going to it's an angle of rotation is plus 90 degrees, so it's turning 90 degrees counterclockwise. Okay, that means if I pick any point on here and the corresponding point on the image, this angle will make 90 degrees. It doesn't matter which one. I chose the tip of the arrow, but I could have chose any one of these points as long as I have the corresponding points. So this one and this one, this one and this one, this one and this one. It's always going to be a 90-degree angle right there. Okay. Now this, here's the center of rotation, this check mark right here. This is an angle of rotation of negative 20 degrees. So it took this and it rotated it 20 degrees that direction. Okay, so pretty simple. Okay, so the vertices of a trapezoid are W is negative 4, 2. So this is negative 4, 2 right here. Let's make this thinner writing. Let's see here. And then my next point is going to be X is going to be negative 3, 4, so that's here. Y is going to be at negative 1, 4, that's going to be right here. And Z is going to be at negative 1, 2, right here. Okay, so what are the coordinates of the image? So I need to find the image. So the easiest way to do this is to just rotate this thing. So if I rotate it 90 degree, or no, 180 degrees, sorry. It said 180 right here. I get this image right here. So it rotated. Notice that here's the it's rotating around the origin, right, which is right here. So this, look at this. This is left 1, up 2. This is going to be right 1, down 2. This one, the W is going to be left 1, 2, 3, 4, and up 2. This is going to be right 1, 2, 3, 4, and down 2, because it's been rotated 180 degrees, so everything's the opposite. Now, what are the coordinates of the points? Well, W is 4, negative 2. X is at 3, negative 4. Y prime, and these are all primes, of course, 1, negative 4. And Z prime is at 1, negative 2. Okay, do you notice a pattern in the coordinates of a 180-degree rotation? So look here, compare W, W with W prime. Oh, the negative 4 becomes positive 4, and the 2 becomes negative 2. And it's the same with all these. Negative 3, 4 becomes 3, negative 4. Negative 1, 4 becomes 1, negative 4. So we can say that xy, here's the mapping, xy goes to negative x, negative y for a 180-degree rotation. Okay. The vertices of a triangle are j equals 1, 2. So if we look here, j is 1, 2. K is 4, 2. 1, 2, 3, 4, up 2. And L is at 1, negative 3. So we want to rotate the angle 90 degrees counterclockwise around the vertex L. Now this is a tricky one. Okay, here's my center of rotation right there. Before it was the origin. Most of the time they have you do the origin. But this one is around L. So, what are the new coordinates? Well, there's my rotation. See, I took it and I rotated it 90 degrees this way. So notice that L prime and L, they're the same point. That's going to happen if you have a point on your figure on the center of rotation. So that's still at 1, negative 3. That's an easy one. Okay, I look here at K, K prime. That's going to be at negative 4, 0. And J prime is going to be at negative 4, negative 3. Okay, so there's the coordinates of my image. Not too hard to do. Okay, so the vertice, and now this one here, there's two transformations. So the vertices of a rectangle are at A equals negative 3, negative 3, right here, negative 3, negative 3. B is at 1, negative 3. C is at 1, negative 5. And D is at negative 3, negative 5. Okay, so the first thing we're going to do is we're going to rotate the angle, the rectangle, 90 degrees clockwise around the origin. So it's going to go this way around the origin 90 degrees. And then we're going to reflect it in the y-axis. So what are the coordinates? So we're going to have two sets of coordinates. Here's my first one. There's my 90-degree rotation. So A prime is now negative 3, positive 3. B prime is now negative 3, negative 1. C prime is now negative 5, negative 1. And D prime is now negative 5, 3. Okay, so do you notice any pattern here between A, B, C, and D, and A prime, B prime, C prime, and D prime? Well, let's see. The X stayed the same. The Y changed. There's not really an obvious pattern here. Okay, so we'll just leave it at this. Here's my new points. What are the coordinates of the image? So that's I have to do another one. I need to reflect this in the y-axis. So it's going to come over here. There's A double prime, B double prime, C double prime, D double prime. So A prime's here, A double prime's here. That's just going to be 3, 3. B double prime, 3, negative 1. C double prime, 5, negative 1. D double prime, 5, 3. Okay, so this right here, this is my final answer right here. Okay, because I had to do two different transformations on this. Notice it's exactly the same shape, okay, because rotations and reflections do not change the shape of anything. Okay, neither do translations. If I were to slide, I could take this and I could slide it somewhere else. I could figure out that coordinate, and I would have A triple prime, and so on. That would not change the shape either. Okay, so check this one out. The red figure is congruent to the blue figure. Describe a sequence of transformations in which the blue figure is the image of the red figure. Okay, so now look at this. This one is kind of leaning to the right. And if you look at this one, if we were to take this thing, it's still leaning to the right. Okay, so I need a series of transformations here. to get from the red to the blue. So what if I rotated this thing? Ooh, I don't have that on here. Okay, so if I rotated this thing this way around the origin, say 90 degrees, so what would that do? That would give me, this point would stay here. This point would come to here. This point, 90 degrees, would come to here. And then this point would come to, that's not right, here. So I get this. And now I can take that shape and I can translate it. Okay, so let's describe it. So the first thing is I would rotate the red pre-image 90 degrees. I got to give direction, so it'd be counterclockwise. Around the origin. That'd be step one. That gives me the green one. So I've gone from the red to the green. Now I'm going to take this, I'm going to translate it 1, 2, 3, 4 up. So the second step is to translate the green image 4 up. And then I would have my blue figure right here. So, piece of cake. Okay, so here's what you're going to do. You're going to do 1 through 25, the odd ones. And we'll do those in class. And I will see you guys next time.